Alright, so we're going to make this video about question 46, but before we do, the answers to question 45. So on A, it ends up being these lines are parallel, so we can tell that right there. There's parallel, they're not intersecting, they're going to be parallel lines. That one was pretty clear. If you remember that parallel lines have the same slope, you actually don't have to do much algebra on that one. On this one's a little bit trickier. I went ahead and replaced x with y squared and ended up here. Solving, factoring here, y is 2 and negative 1, plugging in 2, I get x is 4, I plugged in 2, y squared equals x. Plugging in negative 1, I get x is 1, so I have 2, 4, and 1, negative 1. And so those are the answers that you were supposed to do on your own. I hope you did. And let's move on to our new problem. So consider the system shown below, and here we have a circle with center at the origin and a radius of 5. And then we have a parabola that has been shifted down 13 units. And so it's got a y-intercept of negative 13. It's opening up, that kind of stuff. And so I know I have a circle and a parabola. And when I have a circle and a parabola, there are many choices of how these can intersect. So we can get this kind of a result with 2 answers. We can get this kind of result with 3 where it just touches, and then you've got the other 2 points. And we can get this kind of a result where it touches 3 times. Or we can get it touching once. Or we can have it touching never. So those are our 3 choices. I want you to pause the video now and predict what you think the answer is going to be. Okay, so you should have come up with a prediction. I'm not going to predict anything because I already know, and my prediction is not good, but keep in mind that we can have anywhere from 4 to 0 solutions. So hopefully you've explained your prediction, why you think you have it. If you haven't, again, pause the video and take the time to do this because it's important that you think about what could happen. And then let's go. Oh, the other way it can have no solution, by the way, is this can go around it. Just so you know. Let's see what's going on. So the biggest problem here is my graph paper doesn't quite go down far enough. So I'm going to prepare some new graph paper. You can figure out a way to manipulate it so it'll work for you. I'm going to get some graph paper that will work for me. Here I am, fresh armed with my brand new graph paper. And so I'm going to start with my circle with my radius of 5, center of the origin, radius of 5. I'm going to go 5 out on each of the axes. And then since it's 5, I also know I can do 4, 3, and 3, 4, which we kind of did the other day. And the other thing you can then do is then you draw your circle the best you can. We want to be as accurate as possible so that when we draw our parabola, we can see where it intersects. So there we are. And then we're going to draw a parabola, which had a y-intercept of negative 13, which is why I redrew my graph papers, because I didn't have the 10. Again, if I were you, I'd probably just move up my axes on the graph paper you had, or whatever you can do. Then I'm going to go 1 and 1, 2 and 4, 3 and 9. So it looks like it's meeting. Then 4 and 16. So that's 13, and there's 16. And 5 and 25. I don't know if that'll fit. 13 to there. 15, 16, 15. So not quite. So either way. Oops, 2 straight up there. It is on its way to wider. So just kind of cleaning it up. And there we are. And so were you right? I was, but then again, I kind of knew. The only way I figured it wouldn't have 4 solutions is if it went around it. And so it's really complicated to solve this. So, but it's not impossible. So I see 4 solutions. My prediction was correct. Yours might not have been. Again, looking at your homework from the other day, I think a lot of you didn't realize how many times a parabola and a circle could intersect. Let's combine the 2 equations we had. So we got x squared plus y squared equals 25. And we also had y equals x squared plus minus 13. And so the only variable is x. And so we've got x squared plus x squared minus 13 squared, because I'm replacing y with this, equals 25. So there's my one equation. And I have a feeling I'll need it, so I'm going to just grab it. See how much I actually grabbed there. And combine them in a different way, so the only variable is y. So when I go to combine them for y, x squared plus 25, y squared equals 25. To get y as the only variable, I'm going to have to get, no, actually that's not too bad. Get x squared alone, so we get 25 minus y squared. And so my other equation was y equals x squared minus 13. And so I can replace x squared with, see how I have x squared and x squared, I can replace that way. And so I will have y equals 25 minus y squared minus 13. And so, and then it's just a question of which will be easier to solve. And my thought would be that this one is easier than this one. This one looks pretty complicated. I have to square it, and I'm going to end up with something to the 4th, which again, that's why I got 4 solutions. And you'll notice that the y values, there's only 2 y values. So my y values are both 3 and negative 4. And so that's why we can solve this one more easily, because we're only going to be able to find 2 y values, or we can find 4 x values. And so I would say this second pairing is better, because it's to the 4th power instead of to the 2nd power. To the 2nd power. It's quadratic is my reason. And if we've not already done solve one of my equations from part C, I'm going to do the second one. So I've got y squared plus y equals 12. And so y squared plus y minus 12 equals 0, which factors into y plus 4 and y minus 3 equals 0. So y equals negative 4 and positive 3, which is what we saw in our graph. And then we would go back and plug into the other equations and find our x values. And again, we're going to have multiple x values. It didn't say to solve the system, it said solve one of the equations. So I'm going to not solve my system, I'm just going to solve one of the equations, and that's that. Our next video will be homework. Stay tuned.